Some of the primary components of our design include a solar-powered fan, as well as sliding doors over the windows that could help control the ventilation. There is also a drainage system. The compartments on the left and right sides of the house collect rainwater. The roof of the house is slanted in such a way that directs water towards the compartments in order to collect that water.
As mentioned previously, everything was modeled in AutoCAD Inventor. With our AirBuds theme, we decided we would design it for a Labrador Retriever, which are normally about 42 inches long and 24 inches tall. Design sources recommend that your house be no more than 25% wider than your dog and no more than 50% taller than your dog. Due to material availability, we settled on a 4x4 foot base to make sure our dog still has enough room to turn around and get comfortable, and opted for the maximum wall height, which will allow for more circulation, which will be important during Austin's hot summers, and having a larger space will make it harder for any potentially harmful compounds to infiltrate and linger in high concentrations. Because durability is integral to something's sustainability, we decided that this house should be able to accommodate a 50-year storm in Austin. This will ensure that the doghouse can be enjoyed by a dog lover for multiple generations of furry friends. According to a Texas A&M University's survey of Travis County topsoil, we can expect about 1 inch of absorption from soil before flooding will occur in a storm. This means that to prepare for our almost 9 inches of rainfall, we would want a minimum elevation of 8 inches. However, because we decided to implement a small garden that includes lavender and chamomile, which have an optimal soil depth of 8 to 9 inches, we decided to just go ahead and call it 9. This will allow us to incorporate the ideal garden and make the most of the space and materials. Additionally, the Journal of American Veterinary Medical Association has found that lavender and chamomile can benefit dogs via aromatherapy, and should the dog decide to misbehave and eat the garden, it would be completely safe. Overall, our doghouse's design choices regarding size balance safety with durability with comfort while maximizing functionality. In lieu of physical scavenging, we still scavenged virtually, as the most sustainable options for materials are the ones that you already have or ones that you can save from a landfill, like these 2 pianos that no longer work due to years of neglect. However, the wood is still sturdy and self-supporting, and between the 2 pianos there are multiple boards that are 4x4 feet or greater in area, which is why the floor is this size. For bracing and support, we found a listing for free shelves that were also being thrown out. We would then use a finish called shellac, which is inert and will help prevent splinters and water damage. For roof tiles, I've seen these construction signs end up in my dumpster quite a number of times. These are lightweight, sturdy, and waterproof, which is perfect for a weatherproof roof that doesn't make the doghouse top heavy. Worn bed sheets and pillows can easily be repurposed from home, and we would use piano strings to hang up these sheets as curtains inside the windows for when it gets cold. Excess water will be filtered into the collection drawer through upcycled plastic bottles with cloth, sand, and rocks as filtration so that it can be reused on the garden or other parts of the yard. Lastly, screws, table saws, jigsaws, drills, levels, and other necessary materials for construction would theoretically be available at UT's workshop. Our materials are both creative and sustainable because they prevent waste from being created and money from being spent unnecessarily without compromising structural integrity. Considering expenses for the solar panel, used fan, and the finish, we can expect to spend about $50.
This is a more detailed view of the rainwater collection system. There are compartments located on the right and left sides of the house in order to collect the water that falls from the sides of the roof. The compartments also act as a place to store soil and plant. As one is watering the plants, the excess water is collected. There is a drawer located in the middle between the compartments on the left and right sides. For structural stability purposes, we added some beams arranged in a cross-like pattern. The drawer acts as a reservoir to store the water. The drawer is able to be pulled out for easy access for maintenance and cleaning. Another aspect of the rainwater collection system design would include a water spout for convenient access to water supply. Instead of having to open and close the drawer each time one wants to access water, one may simply use the spout instead. Lastly, there will be filters installed near the sides of the drawer in order to filter out soil or other impurities.
A wooden panel that slides along metal tracks will be installed on the exterior of both windows of the doghouse. This will enable a user to slide the panel open during the summer for increased ventilation and slide it shut during the winter for increased insulation. Additionally, the doghouse will have a solar panel implemented on its roof to power a small 6-volt fan. Summers in Texas entail prolonged periods of exposure to high-intensity solar radiation. Thus, during these periods of elevated temperatures, the solar panel may sustainably provide electricity for the fan to cool the dog.
Our design makes sure that no screws would be exposed. Also, the house is elevated and weatherproof to hold up against storms and runoff. Additionally, the garden grows plants that are not harmful for dogs. Our inert finish, cross breeze, high walls, and roof limit the concentrations of VOCs in the house. Also, the garden's herbs have been shown to provide a calming effect for dogs. Though it might appear generic, our house has repurposed wood from a piano to create a comfortable home environment and water collection system all in one. No part of the doghouse went unused. The elevation gave us room for the garden and drainage system, the windows fit closely to the outside of the wall for easy access, and the door's cross-beaming helped prevent collapse, and the roof's 30-degree angle is ideal for solar-powered fan. The size is appropriate to make a retriever feel safe, and the ramp provides easy access. Additionally, we have climate control with the windows, curtains, and fan for any weather situation. All major construction materials can be found in places where they would otherwise go to waste, and we implemented water conservation and a carbon-free climate control system.
We modeled the house in Inventor and brought it to life in Photoshop, which we were already familiar with, and considered the structure's physicality with balance, support, and sloping towards the water spout.
Not being able to construct the doghouse made it difficult to know what design choices would and wouldn't be realistic, and not being able to measure VOCs and particulate matter within the doghouse meant that we can't gauge how open the windows need to remain for sufficient cross breeze, which is why we opted for sliding windows. One more factor we looked into was insulation. Spray foam, fiberglass, reflective coil were all considered, but after further research and given Texas's climate, we decided that insulation isn't worth the cost or potential VOCs, and our dogs shouldn't be outside in snowstorms anyways. This experience shows us how many materials that could be repurposed still go to waste, and that even construction signs can provide something as unrelated as a home for your dog. Going forward, we might opt for a smaller, more compact design, as this one requires a substantial amount of wood, and there are only so many broken pianos left in the world.